Hello, my dear students. I hope you're all doing well. My name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. So, my dear students, you know that we have been continuing our series solving the numerical problems from the chapter Electricity. So, today we are at question number 12. So, let's start our video by solving question number 12 together. So, the first thing that we do is we read the question together, because I've always been telling you, if you want to solve a numerical problem, read the question and try to understand the question. That is the only way to solving a numerical problem. This is also the only way to solve mathematical problem also. So you have to read the question and understand the question. Then it gets super easy. Okay. So let's read the question and let's solve the question, because this is not a very difficult question. All right. So the question reads, several electric bulbs designed to be used on a 220 voltage electric supply line are rated 10 watts. How many lamps can be connected in parallel with each other across the two wires of 220 voltage line if the maximum allowable current is 5 amperes? So we have read the question and certain things are clear. Whatever things are clear to you, write given here and start writing them, because that is the way to do it. So write here given. The moment you write given, what do you write? The things which you have understood from the question, you write. So by reading the question, we know that there are several electric bulbs. So we can draw some bulbs. Now remember, the word several is used. So I don't know exactly how many are there. So I don't know how much are there. I'm just drawing 2. Okay, you can draw 3, 4. But remember, it's not certain how many are there. Just draw 1 also, it will do. I'm drawing 2. Several electric bulbs are designed to be used on a 220 voltage electric supply line. So the voltage is given to me 220 volt. Now, simple but very important MCQ question for you. In exam, if they ask you, what is the potential difference across our homes in India? Then the answer is 220 voltage. The potential difference coming to your home and my home, okay, is 220 voltage. Something to remember for your MCQ. So, are rated 10 watts. So, what is this 10 watts? Anybody who will tell me what is 10 watt? What is this? This is watt. What is the unit of watt? No, sorry. Which quantity has watt as its unit? The answer is yes, power. So power is given to you. So the power of the bulb is given to you. Power is 10 watt. So power is given to us. Power is given to us 10 watts. How many lamps can be connected in parallel? Remember, the combination is in parallel. But the question is, how many lamps? How many? How many means what? N. We have to suppose to find n. Now this rings a bell, isn't it? We have already solved a question where we have found n. Which question was it? Yes, question number 10. So question number 10 and question number 12, they are almost identical. They are almost same. I should say 95% same. Okay, they are same. So whenever you practice question, so how do you practice this for your exam? Practice question number 12 and question number 10 side by side, because they are almost similar. So when you practice them together. Alright. So we have to find n. So, and what else? Can be connected in parallel. Remember the combination. The combination is parallel with each other across the two wires of 220 voltage line if the maximum allowable current is 5 ampere. So the current flowing through the entire system is 5 ampere. So I is also given to us. So these are the things that we got. So we write whatever things we have extracted by reading the question in given. Now, what do we do? Now, if I were you, okay, now the question is how to solve, how to proceed. So that is what should go through your mind. Now, if you ask me, then, well, how do we proceed? So let me tell you how do we proceed. So we know that our goal, our ultimate goal is to find n. N, okay, the number of bulb. N. N stands for number. So to find n, there should be a formula. Yes or no? Yes. So is there a formula? Yes, there is a formula. Which formula? We will use the same formula which we use in question number 10. So the formula was like this: 1 by R. This is the equivalent resistance, okay? So R EQ and N by R, okay? So this is the formula. This was the formula which we have used in question number 10. So this is the formula for finding N. So N is here. To find N, you need to know the equivalent resistance for a system and also the individual resistance. This is the individual resistance. This is the individual resistance. So the individual resistance talks about the resistance of the given object. So in our question, we should know the individual resistance. We should be knowing the resistance of this bulb. So we need to know the resistance of the bulb. So you need to know the resistance of the bulb because the object in discussion for this question is bulb. So we need to know the resistance of one bulb, and later on we have to find the equivalent resistance also. So if you have equivalent resistance, and if we have the individual resistance, then we can calculate N. So what is our task here? Our task here is to find the equivalent resistance and also find the individual resistance. That means we have to find the resistance of the bulb. So which one should we do first? We'll find the resistance of the bulb first. All right. So let's come back here and now let's write. So let the number of bulb be N. So let's write like this. Let the number of bulb be N. Since the question wants us to find how many lamps, so let the number of bulb be N. Okay, let N be the number of bulb. Now to find the resistance of one bulb, our job now is to find the resistance of one bulb. Let us find the resistance of one bulb. So to find the resistance of one bulb, which formula should we use? We will be using power formula. Okay, since the power of the bulb is given to us, so we'll use this information. So remember, power has got one formula. Power is V into I. This is called the primary formula of power. Very important formula of power. Power is equal to V into I. But there are two more formulas of power. Power is equal to I square R is also there. Power is equal to, okay, the other formula is, if I'm not mistaken, it is V square by R. V square by R. So there are two formulas of power, I square R and V square R. Now, which formula should I use? Which formula should I use? To decide which formula to use, remember this. This formula we will use if the combination is in series. This is used in series combination. This has already been discussed when we were discussing about the types of combination in the video classes. So that makes this to be used in parallel. So this formula will use in parallel combination. Now, in which combination is this? This question is in parallel combination. So that means which formula are we picking? We'll be picking this formula. We'll be using this formula to find the resistance of the bulb. All right. So remember the type of combination. It is very crucial to know the type of combination, because if you know the type of combination, it helps you identify the formula to use. So having identified the type of combination this question is, we can easily know, okay, we can easily select the formula which we need, or else there will be a confusion, is not which formula to pick. And I know most of you have this confusion, which formula should we pick? So remember to pick the right formula, identify the type of combination it is in, and once you identify the type of combination, you will know which formula to pick. Since the combination is in parallel, we will pick this formula because this is the formula for parallel combination. Had it been in series, we'll pick this one, but our question is in parallel, so we'll be picking this one. Okay, now let's see. So we know the formula of power, which is P is equal to V I. Now how do I get to that V square by R? For this we have to use Ohm's law. So P is equal to V by I, but we know V is equal to IR, is it not? So let's derive a formula for I. So I, keep it there, V keep where it is, R will go below V. So this is the formula of I. So P is equal to V into, instead of writing I, write V by R. So P is equal to, you get V square by R. See, this is the same formula as this one, isn't it? Okay, so we have derived this formula. Our goal is to find this R. Okay, our goal is to find the resistance of the bulb. We are trying to find the resistance of the bulb. So put the value of power, which is 10 watt. Put here 10 and V square. V square is how much? 220 into 220, so 220 whole square. R we are supposed to find. So do cross multiplication. But before we do for cross multiplication, let's expand this one. So 220 4 10 is equal to 48400 by R. This is the expanded form of 220. If you multiply 220 into 220, the answer is 48400. Okay, 48400. Now let's go here. So what will happen now? Cross multiplication will take place. So R into 10, and then 48400. So R will be here. 48400 divided by 10. So R is equal to 4840 ohms. This is the resistance of one bulb. That means the resistance of one bulb is found now. It's 4840 ohm. We have just found the resistance of one bulb. Alright. Now, next what do we find? Now we have to find the equivalent resistance. So now let's find the equivalent resistance. So now, okay, equivalent resistance. EQUIVALENT. Equivalent resistance. Now let's find the equivalent resistance. Now we are interested in finding this one. We have already found this one. We have already found the resistance of one bulb. Okay, N is what we are supposed to find. We are ready with this one. Now we have to be ready with this one. Let's find this one, and it becomes very easy. So let's find this one. So to find the equivalent resistance, which formula will I use? I'll be using Ohm's law. Okay, I'll be using Ohm's law. So now equivalent resistance using Ohm's law, which is V is equal to IR. Potential difference is given to us 220. Current we know is 5. R is R. We are supposed to find this R, equivalent resistance, REQ. Okay, so it will be 220 by 5. This is R, our equivalent resistance. So 5 ones are 5, 5 fours are 20, again 2, 5 fours are 20. So R equivalent, our equivalent resistance is how much? 44 ohm. So you have found the equivalent resistance also. So we have found the equivalent resistance. So we have found this also. So now we are ready. We are ready to substitute these values here. Okay. So next, let me erase this one. I hope you have copied down this one. Okay, I'm going to erase this and we'll continue. So let me erase these things. Now remember, the combination is in parallel. So the next step will be to use the formula for the combination. So we write since combination is in parallel, we have, what do we have? We have the formula. Okay, we have the formula which is 1 by Rp, okay, is equal to 1 by R1 plus 1 by R2 plus, it goes on. We don't know how much is it. We are supposed to find N, so it goes on till N. Okay, so 1 by Rp, this is the equivalent resistance. Okay, so this is Rp here, this is the equivalent resistance. Equivalent resistance we have found 44. So replace this one with 44 because this is the equivalent resistance. This is the equivalent resistance. So Req, this is the equivalent resistance, equal to 1 by R1. R2, this refers to the resistance of the bulb. So the resistance of the bulb is 4840. 4840 plus 1 by 4840 plus, it goes on till N. So 1 by 44 is here, and then LCM will give you 4840, and here you'll get 1 plus 1 plus, it goes on till N. So 1 by 44 is equal to, this will give you N, and this will give you 4840. So cross multiplication, so it will be 44 into n equal to 4840. N is here, 4840 by 44. 11 4s are 44. 11 4s are 44. Again 4 in hand. 11 4s are 44. 0. So 4 1s are 4. 4 1s are 4. 4 1s are 4. 0. So n is equal to 110. So we have found the value of n. Okay, we wanted to find n, and we got the value of n. So the question is asking how many bulb lamps can be connected in parallel. So the answer will be, therefore 110 bulbs can be connected in parallel. That's it. This is it, my dear students. This is the answer to the question number 12. So now, was it difficult? No, is it not? It was not difficult, but you need to practice 2-3 times. Okay, so like I said, practice this question and question number 10 together. It will make it very easy for you. So now I'll erase this question and I'll write question number 13 and we'll solve that together. All right, so let me erase this question. So question number 13 has been written. Let's read the question and let's solve the question together. Question number 13 reads, a hot plate of an electric oven connected to a 220 voltage line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately, in series or in parallel. What are the currents in the 3 cases? So we have to find the current in the 3 cases. The question talks about resistance plates or hot coils, okay, hot plates. So how do we draw them? We can draw them like this, okay, spiral. Okay, this resembles one of my favorite food. Which food is it? It's very sweet in nature. Yes, you got it correct. It's jalebi. Okay, I have a sweet tooth and jalebi is one of my favorite food. Okay, I like it. So these are the hot plates. Their names are given to us. It's A and B. The potential difference is also given to us, 220 volt, and the resistance is also given to us. Each plate is of 24 ohms. So we can write this in the given. So write here given and write down whatever information is given to you. Potential difference is given to us, 220 voltage. Resistance is given to us, which is how much? 24 ohms. And what are we supposed to find? We are supposed to find the current. Okay, current. Now we are supposed to find the current when the plates are used separately, when the plates are used in series, and when the plates are used in parallel. Now what do I mean by this? See, when used separately means separate. A is used separately, B is used separately. So when used separately, okay, when we are solving for when used separately, we will consider one plate only. Okay, and whatever answer you got, that will also work for B. So when used separately, we'll find for one plate only. When used in series, you know how series works, isn't it? So for when we use in series, the combination should be in series, and when used in parallel, the plate should be arranged in parallel. So for these 3 cases, we'll solve them separately. So the first one, let's find for when used separately. So number 1, okay, when used separately. So let's find the current which will flow in the coil when used separately. So we are using separately, so let's take only one. Okay, so this is the one coil. Okay, so when used separately, well, we know that the voltage is same, resistance is same, and current, we are supposed to find current. So when used separately, let's directly find the current. So here, so how do we find the current? We can easily find the current using Ohm's law. Okay, Ohm's law. So when used separately, the voltage will be how much? 220 volt, same. The resistance of this plate is 24 ohms, and we are supposed to find current. So current we are supposed to find. So using Ohm's law, you solve it. Using Ohm's law, which is V is equal to IR. V is 220 volt. Current we are supposed to find. R is 24 ohms. So 220 is here, 24 will go below 220 I. So let's cut with 2. 2 ones are 2, 2 2s are 4, 2 ones are 2, 0 10, 2 6 are 12, 2 5s are 10, 2 5s are 10. So what you're getting, 55 divided by 6. So divide 55 by 6. So 6 will divide 55. So we divide 55 by 6. On dividing 55 by 6, what we get? We get 9.16. So the answer is I is equal to 9.16, which can also be written as I is equal to 9.2. We are rounding off 1. Okay. So 6 being greater than 5 can help in rounding off 1. So the answer becomes 9.2 amperes. So the current flowing through each coil when they are used separately is 9.2 amperes. That means the current flowing here is 9.2 ampere. Okay, so 9.2 ampere current flows through A, 9.2 ampere current flows through B also, because they are same, isn't it? Okay, they are both same coils only. So this is the answer for when used separately. Now we'll go for the second one, which is when used in series. So keep this here. Now go to the second one. So when used in series. So now it will be used in series. So these two plates, these two resistances, these two hot plates, let's connect them in series. So if we connect them in series, okay, how will it be? The figure will look like this. This is it. Plus, minus, plus, minus, plus, minus. So this is 220 voltage. This is 24 ohms. This is 24 ohms. So the two plates are now connected in series. So this is how the figure will look like. So here, what things we know? Same thing, okay. The voltage we know is 220 volt. The resistance of each coil is again 24 ohms. And we are supposed to find current. Again, we are supposed to find current. Since the combination is in series, let's find the equivalent resistance. Only after you find the equivalent resistance, then only you will be able to find current. So let's first find the equivalent resistance. So since combination is in series, so the formula will be Rs is equal to R1 plus R2. In case you are wondering what is R1 and R2, this is R1, this is R2. Okay, so R1 plus R2. R1 is 24, R2 is also 24 ohms. So R1 and R2, 24 plus 24, 4 plus 4, 8, 2 plus 2, 4. So 48 ohm. So the equivalent resistance is 48 ohm. Alright, the equivalent resistance which acts on the system is 48 ohms. Now we are ready to find current. So how will we find current? We'll be using the same formula, Ohm's law. So using Ohm's law, we have, so write Ohm's law, V is equal to IR. V value is 220 volt. Current we're supposed to find. Resistance, we'll be using this one. And then let's continue here. So I will be there, 48 will come below 220. So I is here, keep him there, 220 is here, and 48 will come below that. Alright, so now let's cut this one. Let's cut this. 2 to the 4, 2 4 the 8, 2 1 2 1 10, 2 1 the 2, 2 to the 4, 5 and 5. So I, we're getting us 55 divided by 12. So 12 will divide 55. So do the division. Do the division of 55 divided by 12, and what you get? You get I value to be how much? It will be 4.6 ampere. So this is the current which flows in the system when the resistances are connected in series. Okay, so now we'll have to find the third one, which is if the combination is in parallel. So number 3. So now let's check for number 3. We write when connected, when used, or when connected. We can write when connected. When connected. When connected, when used, same only. When connected in parallel. So when connected in parallel. So now it is in parallel. So the figure will also change. So the figure will change and it will look like this. This is the form. This is the figure. So each resistance is of 24 ohm. This is your R1. This is your R2. So the same thing is here. Okay. Here you have to write those things. So here potential difference is same, 220 voltage. R resistance, okay, R1 you can write it as 24 ohm. R2 you can write it as 24 ohm. Then current is what we are supposed to find. Okay, but before we find current, we will have to calculate the equivalent resistance for the system. Then only we can find current. So let's find the equivalent resistance. So since combination is in parallel, since combination is in parallel, we'll have to use the formula for parallel, which is 1 by Rp is equal to 1 by R1 plus 1 by R2. To calculate the equivalent resistance, you need to know the type of combination. Here the type of combination was in series. We have a formula for calculating that. Here it is in parallel. We have a formula for calculating that. So 1 by Rp is equal to 1 by 24 plus 1 by 24. Now reminder, a very important reminder to my dear students, whenever you are solving for parallel, do not skip this one. Always keep on writing the LHS, okay, because later you have to go for cross multiplication. I see many students, okay, they don't write this one and then they end up getting the wrong answer. You are to always write this LHS. Keep on writing 1 by Rp until unless you go for cross multiplication. So 1 by Rp, LCM is 24, so 1 plus 1. So I think let's erase this. We don't have spaces, so let me erase this and do it here. So let's bring it all the way from here to here, okay, such a long drive. So 1 by Rp is equal to 1 plus 1, 2, 2 by 24, 2 ones are 2, 2 ones are 2, 2 twos are 4. So 1 by Rp is equal to 1 by 12. I am talking about this one, this very part. If you do not write 1 by Rp, okay, you will end your answer here, 1 by 12, which is wrong. Now you will go for cross multiplication. So Rp into 1 will give you Rp only, and 12 into 1 or 1 into 12 will give you 12. So this is the equivalent resistance. This is the equivalent resistance, which many students make mistake because they don't write this LHS. They just write this equality and then they do it and then they end up getting the wrong answer. So this is where you are making mistake. Always write the LHS also, so that it will help you in the cross multiplication. Remember, to find the equivalent resistance for parallel, you have to do cross multiplication. Alright, so you have found the equivalent resistance. Now the question wants us to find the current in the current only. We have already found for the first two. Now we are gonna find for this one. So how do we find the current? We have the potential difference, we have the equivalent resistance, and we need I. So Ohm's law is there for us. So using Ohm's law, Ohm's law is V is equal to IR. V is 220 volt. I we are supposed to find. Resistance is 12. So 220 is here. Bring 12 here. Keep I there, it is. Cut. 2 6 are 12. 2 1 1 0. 2 3s are 6. And 2 5s are 2 5s are. So I value, you will get it as 55 divided by 3. So what we do is, we divide 55 by 3. So 55 gets divided by 3. So if 55k is divided by 3, what do we get? We get the answer as 18.3 amperes. So this is the answer. So this is the answer for question number 13. Now let me erase this and let us do one more question, question number 14. So question number 14. Question number 14 has been written. Let's read the question together and solve it. So the question reads, compare the power used in the 2 ohm resistor in each of the following circuits. Case number 1, a 6-volt battery in series with 1 ohm and 2 ohm resistor. And case number 2, a 4-volt battery in parallel with 12 ohm and 2 ohm resistor. So this question will be solved under 2 cases, case 1 and case 2. In case 1, we will address this issue, and in case 2, we'll be addressing the second issue. So let's break it into case 1 and case 2. So in case 1, we will discuss the first case, okay, when a 6-volt battery. So what is given, you write down, voltage is given to you, it's 6 volt, and then the combination is in series. We'll do that. First of all, the resistances are given to us. R1 we can write it as 1 ohm, R2 we'll write it as how much? 2 ohm. Let's draw the figure, series, so it will look, the series combination has to be drawn like this, plus minus plus minus plus minus. This is how the figure will look like, okay? And R1 is 1 ohm, R2 is 2 ohm. If you read the question is asking to compare the power used in the 2 ohm resistor. That means here our primary focus should go here, okay? We are to calculate the power, okay, used in the 2 ohm resistor. So here we are to calculate the power here, okay, when they are used in series, and in the second case when they are used in parallel. So we are going to find power. So we need power. So power is equal to V into I. This is the primary formula of power, okay? Potential difference into current. But if you remember, in question number 12 and in question number 10, there are formulas of power, okay? 2 formulas of power. From the primary formula, we get 2 more formulas of power. One is P is equal to I square R, and the other is P is equal to V square by R. And by now you know very well that this formula, we use it in series and we use this in parallel. By now you know that this formula is used in series and this formula is used in parallel combination. But my dear students, here's a big question which I want to ask you. The question is, why do we use this formula in series and why do we use this formula in parallel? Why? Can anybody tell me why this formula is specifically used in series and why this formula is specifically used in parallel? I'll give you one moment. So pause the video and think. Yes. So what have you come up with? Why is this video why is this video, no, why is this value, okay, why is this formula, not even value, why is this formula used in series and why is this formula of power used in parallel? Here is the answer. See, my dear students, in series combination, if I ask you what remains constant, what remains constant in series, what remains constant in series combination? Yes, in series combination, current remains constant, is it not? Current remains constant. So that is a reason why the formula for power should have current in it. Understood? So the formula for power when the combination is in series is this. Now you know the reason why this formula is specifically used for series combination. Likewise, the same explanation we will use for parallel. In parallel combination, if I ask you the same question, what remains constant, what is constant in parallel combination? Your answer is potential difference, is it not? V remains constant. So in the formula for power, if the combination is parallel, should be this, because potential difference remains constant. The formula for power in series combination should have current because current remains constant. I hope that clarifies your doubt why this formula should be used in series combination and this formula should be used in parallel combination. It's all because of their constant values. So I hope you are clear by now. Okay, so one by one, the different questions discussed in the exercise, they help you build more concept. Okay, you get to learn more by solving each numerical. So this is what I will tell you, my dear students. Okay, you have understood we have covered the lessons, we have done the explanation, we have discussed the whole topic, and you have notes to study. But you are missing out so much if you don't try the numericals, because numericals will really trigger you, and that is the reason why most of you dread numericals. You don't like numericals because it lets you, it twists you around and it makes you confused like that. But you know what, once you overcome this, your grip on the lesson is very good. So that's why I encourage you, I will encourage you who is viewing this video, that not to give up but to try numericals. You have numericals from electricity, you have numericals from light chapter, and that's it. For class 10 you have 2 chapters where numericals are asked. One is from this lesson and the other one is from light, and both are easy. Both are very easy. Light numericals are super easy, and electricity numericals may be a little tougher than light, but then still it's not that difficult. If you consider this difficult, go to class 11 and 12, and there you will know the level of hardness. In class 10 is this much, in class 11, 12 it raises this much. All right, so the difference is way too big, so you have to prepare yourself from class 10 itself. So let's continue. So yes, we are supposed to find power, and the formula for power that we will be using is this. So P is equal to I square R. We are going to use this formula, P is equal to I square R. Now if you observe the formula, we need I, we need to know the current. So we need to know current for the system. So we have to know the current for the system. So now let's find the current. But we cannot just find the current. In order to find the current, we'll be using Ohm's law, but Ohm's law is V is equal to IR. So we will be using this formula to calculate the current. So let's first find the equivalent resistance for this combination. So what we will do is we'll address the combination. Since combination in series, so RS, let's first find the equivalent resistance, which will be 1 plus 2 ohms. So it is 3 ohms. So you have just found the equivalent resistance for the system. Now you are ready to use Ohm's law. So using Ohm's law, which is V is equal to IR. V value is how much? 6 volt. Current value we are supposed to find. Resistance, we'll use the equivalent resistance, which is 3. So this is 6 divided by 3. I is here. 3 ones are 3. 3 2s are 6. So the current value which we get here, let's write it here. The current value which we get here is how much? We're getting 2 amperes. So we have found the current to be 2 amperes. Now everything is ready. This is the formula we'll be using. So now P is equal to I square R. I square, we just found I, which is 2. And then resistance. The resistance is, we have to find the power using the 2 ohm resistor. So the resistance value will be 2, because the question is asking us to find the resistance across this only. Across the 2 ohm resistor. They want to know the power in this. They want to know the power across this resistor 2 ohm. So R value will be 2. So it will be 4 into 2, which is how much? 8 watt. This is the answer. Alright, this is the answer. So we are done with the case 1. Now we'll do the case 2. So let's go to case 2. in case 2, a 4-volt battery in parallel with 12 ohm and 2 ohm resistor. So in case 2, V is given to us how much? 4 volt, and then R1 is given to us, how much is R1? 12 ohm, and R2 is given to us, R2 will be 2 ohm. So R2 is 2 ohm. This is in parallel, na? Yes, it's in parallel. So let us draw the figure. So let me draw here in the graph. It's in parallel, so it will be drawn like this. So this is your 12 ohm and this is your 2 ohm, and they want us to find the resistance. They want us to find the power across this resistor, 2 ohm. Now now this is in parallel. Okay, in parallel. Since it is in parallel, and then they want us to find the power across this. So the formula for power is V squared by R. So all we need is potential difference and resistance. Now we know that the potential difference in parallel, okay, is same. So the potential difference is already given to us, it's 4. So the potential difference for the system, we know potential difference is 4 ohm. The potential difference across this point and this point is same. In parallel combination, potential difference remains same. In series combination, current remains same. This is in parallel combination. Potential difference remains same. Whatever value the question is given us, which is 4, okay, that will be the value of potential difference for this. So we have, so power, directly we can use power here. Power is equal to V squared by R. We have, so power value we are going to find, V square will be, how much is V square? It is 4. So 4 square, and then this is R value is 2. We are supposed to find the power across this resistance, 2 ohm. So R value will be 2. So P is equal to 4 into 4 divided by 2. 4 square means 4 into 4, na? 4 square, which is 4 into 4 only. So P is equal to 2 ones are 2, 2 to the 4. So you are getting 4 into 2. So power is equal to 4 to the 8 watts. So this is the answer, my dear students. This is the answer for question number 14. The answer is 8 watts in both the cases. In case 1 also, the answer is 8 watts, which is here. And in case 2 also, the answer is 8 watts. So this, my dear student, is a very important question. Okay, I'll put it under the very important category because of the concept used here. It is in this question that you get to understand why this formula is used in series and why this formula is used in parallel. So it has been explained in detail. So this is it, my dear students. With this question, I'll end the video here, and we still have 3 more questions, 3 more numericals. Question number 14. So now 15, 16, 17, these 3 questions will be discussed in the next video. So make sure that you watch the video and learn. So I'll take my leave here, and I'll see you in the next video.